Dear students, very good afternoon. Today we are going to discuss about introduction to embedded system. In that we are going to discuss processor selection for an embedded system. Okay, so let's discuss how to choose processor for an embedded system. Processor selection is not easy task for an embedded system. It is not possible to simply select a processor from your favorite list. Several factors are to be considered while selecting a processor for an embedded system because embedded systems are designed to operate in different climatic conditions, environmental, critical environmental, etc. Depending on types of applications, the necessary performance, power constraints, special processing, modern technology, etc., the processor is selected. There are different types of embedded processors are available in the market. The selection of embedded processor should enhance the user experience by reducing the chance of poor speed, system overheating, insufficient memory, etc. The embedded system in the customer hands should not make them curse their designer. Instead, the system should make them proud of technology. Hence, utmost care should be taken in the selection of embedded processors. So, what are the parameters we have to choose? We have to concentrate on selecting embedded processor, type of application, the necessary performance, power constraints, special processing, modern technology, etc. The processor is selected. The factors for selection of embedded processor is speed and performance, optimal power usage, peripheral support, advanced processing, cost. First, we can go for speed and performance. The most important factor to consider when choosing a processor for an embedded system is its performance. A processor speed is primarily determined by its architecture and silicon design. The number of instructions executed per second and the number of operations per clock cycle must be evaluated for accessing the performance. The advancement of fabrication techniques enabled the packing of more transistors in the same area, reduced the propagation delay. Furthermore, the presence of cache reduces the time required to fetch instruction per data. Processor architecture that support additional instruction can aid in improving performance for specific applications. Pipelining and superscalar architecture boost processor performance even further. Multi-core processor are the new trend in the performance enhancement. Next one is the optimal power usage. Increasing the logical density, the clock speed have an adverse impact on the power requirement of the processor. Faster charging and discharging cycle in a capacitor, leakage current may lead to more power consumption. More logic gates to higher power density, thereby making heat dissipation difficult. With more emphasis on greener technologies, and since many systems are becoming battery operated, it's important to design a system for optimal power usage. Next one is the peripheral support. Apart from the processor, the embedded system has many other peripherals to perform input output operations. It's important to have the right peripherals to assist the processor in optimized performance. In recent days, almost all the processor used are SoC, that means system on silicon. So it's better if the necessary peripherals are available in the chip itself and are called on chip peripherals. It's offer various benefits such as optimal power consumption, effective data communications, and compared to external peripherals. The peripherals set located outside the SoC but on the same PCB is called off-chip peripherals. Next one is the advanced processing. Along with the core processor, the presence of various co-processor and specialized processing units can add more value to the processing performance. The instruction fetched by the co-processor are executed by the co-processor in parallel, thereby reducing the processing load. Some of the popular coprocessor include floating point coprocessor, graphics processing unit, digital signal processor, etc. Floating point coprocessor can be very helpful in applications involving complex mathematical operations including multimedia, imaging, and codec. GPU or the GPU graphical processor unit are used to accelerate the 3D graphics in gaming applications, video, and content creation. Artificial intelligence and machine learning application. For example, Intel Iris Xe Max is the GPU along with the 11th generation Intel Core processor provide advanced graphic performance and immersive gameplay. DSP processor that designed specifically for signal processing application. It is architecture support the processing of multiple signal at a faster rate. It can manipulate real-time signal and it's used in different applications like telecommunication, image processing, signal processing, navigation system, etc. So now it's the time for assessment. Students, I hope you understand what are the parameters we have to think on processor selection to design an embedded system. Okay, so what list the types of processor used in embedded system? First, we have to list the processor used in the embedded system design. How increase the speed of the processor by means of more number of silicon area have to be reduced. How performance of the processor is calculated? So we have to answer this. Now it's the time for summarization. So thank you, students. I hope you understand the concept of processor selection in an embedded system. It is a very, very important topic. Thank you all. Have a great day.